This lesson is 5.5 from your book. This is about multiple angle identities. So the first one we're going to talk about are called the double angle identities. This means we have a double angle. So instead of theta, we're talking about like cosine, sine, tangent of 2 theta. That's our double angle. So we can derive these double angle identities from our sum identities that we learned about last time, because 2 theta is just equal to theta plus theta. So we're going to use that with our cosine of alpha plus beta. Both of our alpha and our beta are just going to become theta, for example. So if we're looking to find cosine of 2 theta, we're going to use our cosine of alpha plus beta equals cosine of the first times cosine of the second minus sine of the first times sine of the second. So that means we have cosine of theta plus theta, so our first and our second are both equal to theta, which means cosine of 2 theta equals cosine theta times cosine theta minus sine theta times sine theta, which means we have cosine squared theta minus sine squared theta. That's it. So that's your first double angle identity. So for the second one, we're going to talk about what is sine of 2 theta. So again, we're just going to plug in theta for both our alpha and our beta, because alpha plus beta will be theta plus theta, which will be equal to 2 theta. So we have, for our sine identity, we have sine of alpha plus beta equals sine of the first times cosine of the second plus cosine of the first times sine of the second. So we're going to have sine of theta cosine of theta plus cosine of theta times sine of theta. Well, we have a cosine times a sine in both of them, so we have 2 cosine times sine, which means we just have 2 cosine theta times sine theta. So that's it for the second one, 2 cosine theta sine theta, or 2 sine theta cosine theta. So for this last one, we have tangent. We know that for tangent alpha plus beta, we have tangent of the first plus tangent of the second over 1 minus tangent of the first times tangent of the second. So again, we're going to just fill in, this is tangent of 2 theta. We're going to fill in thetas for all of those. So we have tangent theta plus tangent theta over 1 minus tangent theta, which means we have 2 tangent theta over 1 minus tangent squared theta. So that is what you get for tangent of 2 theta. We can rewrite these and we get something called power reducing identities. What you're doing is you're just solving for the sine squared, the cosine squared, or the tangent squared in these equations in order to rewrite them. We can derive additional double angle identities for cosine if we use the Pythagorean identity. Now we all remember what the Pythagorean identity was. That was our x squared plus y squared equals 1, or our cosine squared plus sine squared equals 1. Now we can rewrite this Pythagorean identity with reference to cosine squared or sine squared. So we could have, if we wanted to rewrite this as cosine squared equals something, it would be 1 minus sine squared. Or if we wanted to write it as sine squared equals something, it would be 1 minus cosine squared. So we haven't really changed that Pythagorean identity, we're just rewriting it a little bit. And that way we can plug in other things. So for this first one, let's say we wanted to plug in our 1 minus sine squared for cosine squared. So we have cosine of 2 theta equals, instead of cosine squared theta, we're going to write 1 minus sine squared theta minus sine squared theta, which means that cosine of 2 theta is also equal to 1 minus 2 sine squared theta. Now, if we wanted to instead plug in something for the sine squared theta, if we wanted this, we actually have a negative sine squared theta, so we can make everything negative. And we would have negative sine squared theta equals negative 1 plus cosine squared theta. So cosine of 2 theta equals cosine squared theta minus 1 plus cosine squared theta, which means we have cosine of 2 theta equal to 2 cosine squared theta minus 1. So those are just different ways to rewrite that. Really, if you can remember the sum identities that we were talking about before, you can derive all of these and figure these out and rewrite them. Sum identities and Pythagorean identities are going to allow you to get all of this information. So these are all of those double angle identities written out just so that you have them for your record. I would highlight these or make notes on them or try to derive them yourself. So the last thing we're going to talk about in this lesson is half-angle identities. So this is talking about when we have theta over 2. So we can derive the half-angle identities from those power-reducing identities we found before. And those are the ones that I said are up here, these power-reducing identities, where you just have cosine squared is equal to 1 plus cosine of 2 theta over 2, for example. So we're going to use that one here. I'm not going to derive all of them right now. We're just going to derive cosine, and then I would recommend really memorizing these half-angle identities. So we have, for example, our cosine theta over 2 equals plus or minus the radical of 1 plus cosine theta over 2. So we're going to try to prove this. We're going to start with this 1 plus cosine theta over 2 all under the radical, and we're going to prove that it's equal to cosine of theta over 2. So the first thing we can do is rewrite this as, instead of just cosine theta that we had in here, we can write it as 2 times theta over 2. We're just going to call this theta over 2 our x for now, and we'll come back to it later. So if we have 1 plus cosine of 2x all over 2 all under the radical, we know that from those power-reducing identities, 1 plus cosine of 2 theta over 2 is equal to cosine squared theta. So we're going to write this 1 plus cosine 2x over 2 just as cosine squared theta because those two are equal. Well, now we have the radical of cosine squared x, sorry, I keep saying theta. We have radical of cosine squared x, which means that we just have cosine of x, and we said that our x before was just cosine of theta over 2. So that's a really simple way to find that cosine theta over 2 is equal to the radical 1 plus cosine theta over 2, but again, I would remember that. It's easier to memorize those. So the sine theta, we have 1 minus cosine theta over 2. Cosine theta, we have 1 plus cosine theta over 2. Both of those are under the radical. And it has a plus or minus out there. The plus or minus is determined by where it is on your unit circle. And for the tangents, we have tangent of theta over 2 equals plus or minus 1 minus cosine theta over 1 plus cosine theta. So, and then you can rewrite tangent if you use some of those other identities. So that's it for your double angle and your half angle identities.